Security is the basic requirement of an application. Secure coding is a broad topic and beyond the scope of one presentation. But in a more general way, we can say that it is the practice of developing APIs in such a way that it guard against the accidental introduction of security vulnerabilities. So, what is secure code? The code that is considered secure is a code that follows best practices and industry standards for protecting against potential security vulnerabilities. To some extent, it depends on the choice of the language too. And Java, as we all know, by design is considered as one of the most secure languages of our time. But still, there are some journal guidelines, or we can say best practices, to follow while writing code, about which every developer must be aware of. So, what are these common ways to secure the code? The first one is the very basic one, and that is input validation. That is verifying that all input is valid and meets the expected format and constraints. This can help prevent attacks like SQL injection and cross site scripting. The second one is exception handling, properly handling the exceptions and errors to avoid revealing sensitive information to attackers. Next is authentication and authorization, implementing secure authentication and authorization mechanisms to control access to sensitive data and resources. Another way can be cryptography, use of strong encryption algorithms and key sizes to protect sensitive data like passwords and credit card numbers. By having the proper access control mechanisms, use the principle of least privilege to ensure that code and data is only accessible to authorized users and processes. Use of libraries and frameworks that have been reviewed and are known to be secure, and be sure to keep them updated. By having the secure communication, that is, use of secure protocols like HTTPS to encrypt communication between the client and server, through proper logging and monitoring, implementing logging and monitoring to detect and respond to security incidents, by following the secure coding practices, follow good practices like avoiding the use of hard coded credentials, avoid using reflection for sensitive information, and not allowing any kind of untested code to execute. And finally, we can say by regular testing. Regularly test the code for vulnerabilities using tools like static code analyzers, dynamic code analyzers, penetration testing, fuzz testing, etc. So, these are some common ways to secure the code. And it is always important to stay up to date with the best practices, the latest trends, and the vulnerabilities. Now, let's see what are the Oracle's official guidelines for secure coding. So, yes, there is a detailed secure coding guidelines documentation that is available at Oracle platform. It talks in length and breadth about the secure coding practices to be followed by Java programmers. We will only first see the fundamental guidelines that have been suggested by the platform. So, at the very first point, it says prefer to have obviously no flaws rather than no obvious flaws. That is, design and write code that does not require clever logic to see that it is safe. And for this, it says specifically follow the guidelines in this document unless there is a very strong reason not to. The next point that has been mentioned is design APIs to avoid security concerns. So it is better to design APIs with security in mind. Next, it says avoid duplication. So, duplication of code and data causes many problems, as we know, and that should be avoided. The next point is restrict privileges. Because if the code is operating with reduced privileges, then exploitation of any flaws is likely to be thwarted. Here, low-level mechanism available from operating systems or containers can be used to restrict privileges and are recommended over higher-level mechanisms like Java Security Manager. The next guideline is establish trust boundaries. So, in order to ensure that a system is protected, it is necessary to establish trust boundaries. Data that crosses these boundaries should be sanitized and validated before use. Next, we have minimize the number of permission checks. So, Java is primarily an object capability language, as we know. And it says that security manager checks should be considered a last resort. Perform security checks at a few defined points and return an object, a capability that client code retains so that no further permission checks are required. The next point is the very obvious point, and that is encapsulate, that we all know how to do. Like fields of objects should be private and accessors avoided. So the overall idea is that the interface of a method, class, package, and module should form a coherent set of behaviors and no more. The next point is, and a very important point is, document security related information. So in that it says that API documentation should cover security related information such as required permissions, security related exceptions, caller sensitivity, and any preconditions or post conditions that are relevant to security. And APIs should also clearly document which checked exceptions are thrown, and in the event an API chooses to throw unchecked exceptions to indicate domain specific error condition, should also document these unchecked exceptions so that callers may handle them if desired. So, including the checked exceptions, unchecked exceptions in the API documentation has been suggested. And the last point is in the fundamental section that secure third party code. So as you all know that we use the library, frameworks and other third party software, but they can introduce security vulnerabilities and weaknesses too, especially if they are not kept up to date. So therefore it is important to keep track of security updates for any third party code being used and make sure that the updates get applied in a timely manner. This includes both frameworks and libraries used by an application, as well as any dependencies of those libraries or frameworks. So, this is what the official guidelines on secure coding suggest that are available at the Oracle's platform. And these fundamental guidelines give a glimpse or an idea about how we can have or how we can implement the secure coding in our application. So, to conclude these guidelines, finally, we can reiterate that the most effective approach to minimizing vulnerabilities is to prefer to have obviously no flaws rather than no obvious flaws, which is the first point. Nowadays, we are also hearing talks around the shift left approach. So, what is that? The shift left approach in software development refers to the idea of moving certain activities or tasks earlier in the development process. This can include activities like testing, security, and performance optimization, which are traditionally done later in the development. So, by shifting these activities to the left, or we can say to earlier in the process, developers can identify and address issues sooner, potentially reducing the overall time and cost of development.